Everybody, it's Tyler here at the Texas Championship, checking in team number 3310, Black Hawk Robotics. Phenomenal team we've been following for many years here on Behind the Bumpers. And tell me more about this team. I have Thomas, Alex, and Adam. And this machine is just so efficient. We just watched them play a match a little bit ago. The way that the cargo just moves through is slick like butter, man. So can't wait to tell you about that cargo journey. They're awesome, the climber they have. All this coming up here on Behind the Bumpers. Your destination for first content, updates, and gaming.
Welcome to the fun.
First Updates Now is supported by Stryker Careers. First alumni and mentors are making Stryker a top priority for their internships and careers. That's because Stryker knows that those in First are the leaders and innovators of tomorrow. If you want to help make the world a better place by creating life-saving medical devices and technology, get started at careers.stryker.com. If you are planning on attending the World Championship, come meet others in the Fun and FRC Discord community with our combined meetup on Friday, April 22nd at 11 a.m. local. Location will be announced closer to the event, and you can stay updated by following in either the Fun or FRC Discord. Starting on your robot, we're going to talk about the intake. Love to hear more about kind of the thought process, the design process behind it, any changes you might have made as well, too.
So this intake was heavily inspired by our 2020 intake from Infinite Recharge. And so what we did was, initially we essentially just scaled it up and changed the geometry a little bit. So one of the first iterations we made is at Waco. This thing just completely snapped around here about 5 times, almost half a dozen.
Oh, wow.
And so you can see that there's 2 plates of 1/4-inch Lexan now instead of just the one, and it hasn't snapped since. It's been pretty durable. And we also added flex wheels on this bottom row because they just grip a little bit better. Another thing is that last competition in Irving, we had a little a mesh tongue that came out here, and essentially what that would do is better grip the balls, but there was a problem where we couldn't get to safe zones in order to launch, and we just rack up penalties.
Sure.
And so these bumpers are actually covered in a little bit of an adhesive that grips the balls a little bit better. Another significant improvement that we made is we added this motor, which we were able to add by getting rid of some VRMs and moving some sensors around. And essentially what it does is it just brings the entire thing in, so that way, like I said, it reduces the amount of penalties that can happen. It makes it to where it doesn't get snapped nearly as much. And those are all pretty significant changes.
I gotta say, it's interesting you mentioned the bumper thing, because I've actually talked to a couple teams, I know you guys aren't doing this, but who've actually sworn that using this type of material is fantastic for defense, because when they hit another robot, it kind of sticks a little bit. So I'm sure you guys haven't experienced that yet.
I mean, I can't attest, we don't really do that much defense, but we've been pretty happy with this material. This is the first time we've used this side of it. Before, we've had bumpers made out of this, but we've been using the other end of it, and it's been fine, but it's just not sticky enough. You know, these balls, they need an adhesive something to adhere to. And so this has been working out so far today, and I hope it keeps working for us.
Speaking of which, can we see a piece of cargo actually go in your robot? Would that be all right?
Adam.
Check that out.
Want to grab one? And then let's see here.
So when you guys are looking at bringing this in and doing the indexing in the middle here, I know you mentioned you made a couple things for it, but did you have jams or anything like that earlier, or was it just kind of bouncing out?
So generally speaking, jams mostly happen around here.
Okay.
Jams don't tend to happen in the indexing as much. If they do, it would end up being probably a software issue, but we haven't had any, so not really much jams going on up there, no.
And then as you go into your S-curve, before you get into your shooter here, we've seen quite a few more teams go kind of that S-curve design. Why was that a good fit for 3310 this year?
So the simplest way to put it is essentially, this is also another borrow over from Infinite Recharge, is just that it's essentially, Alex can tell you a lot more about this, but the S-curve is just really nice because it is just convenient. It was convenient enough to where it could hold 2 balls no matter what, and it would just be able to index things really easily. Whereas if you try to do an intake, it's just not enough room. But the S-curve really just allows for a minimal amount of travel distance to just immediately into the shooter.
Yeah, nice packaging with it too, right? So I appreciate that time. Well, actually, let's go to Alex, talk more about the shooter, and then if there's anything else from that indexing you want to mention as well too.
Okay, so it goes in through the intake and it gets into this indexer right here. And once it gets into the indexer, we actually have a little IR sensor on the inside that detects when there's a ball there, instantly stopping this indexer, but the intake can still run because they're 2 different little subsystems. So then once we have a full salvo of balls, We then feed the balls up through this S-curve into the shooter, which we designed using a prototype from last year, where it was just a singular wheel down here. And while doing that, we didn't have like the actual official goal set up, so we were shooting them and they were going in and sticking. But when we actually got the little funnel goal set up, we realized that, hey, all of them are like going in and spinning all out, and we really need some way to reduce the backspin.
Yeah.
So we added this top wheel here, which is actually scaled up with a gear ratio here. And then we took the variable hood we had from last year and just scaled it up and put it on here, which we determined like the different shots we wanted to do and used an interpolating tree map to figure out the RPM and the hood angle at any point on the field.
One of the things I was just going to say is that I noticed as I followed your belt in here, I was trying to look for the motor and where it was for this. Is the motor all the way? It's all the way down here packaged, or where is it?
The motor's down on the inside here. If you come around here, the motor's right inside here. And we had to do that because there's simply not enough space up here to fit a motor.
When you were looking from the shooter into this, like, how did you gauge like how much actually like compression you wanted on like the cargo, and then from your shooting itself, can you just talk about a little bit about if you do anything different with like the limelight or tracking or anything like that at all?
Yeah. So for compression, we actually using the prototype, we've used different size wheels to figure out what kind of compression we wanted. And a lot of people on Chief Delphi were saying, oh, we're using 2.5 compression. We're running like different tests to see which one is the most optimal, and we're graphing it all to see which one gets right where we want at the minimal RPM, so we're not wasting power. And we figured 2 inches, 2 inches was the sweet spot for it all. And another thing to note is we actually keep the shooter running all match, so we can keep the RPM consistent and we're not having to restart it every time and fight the inertia every single time to get it moving.
Well, let's wrap up on your robot, talking about your climber. It has looked absolutely phenomenal, the events that I've seen, so Adam's going to talk more about that. And I'd love to hear more about the climb sequence as well, too, that goes into it.
Yeah, right. So we have 3 stages to our climber. We have this initial first elevator here. This is the only one that it's the only controlled system throughout our climb. Everything else can just be controlled passively. These are what we call the swords. They're not passive, they are powered right now, but once they go up, they stay up. They can just stay up there. And then these are what we call the spheres. They deploy just with a constant force spring. They're just linear actuated. So.
Can we deploy it and just kind of walk us through each step as it's going through?
Yeah. You want to do that, Alex? Or? So that's the sword deploy, and then we raise the elevator up. And then that'll pull us back down, all the way down to the bottom of our frame. And at that point, our bumpers will pretty much be right below the midbar. And then these will react off the high bar. It'll follow pretty much just like cam surface here. And once it hits this bump, these hooks will just pop right into place, right on the traversal bar. And then we can release from the bottom with this elevator, and we'll swing into the player station. And that's our climb.
So 3310, I haven't timed it, but I know, it has got to have a top 5 fastest climber in the world, right? As we've gone through. Have you timed it?
We have. The one we're running right now is about 4 seconds without lineup, but...
Very cool. So when you're looking at it from a game strategy standpoint, we've seen some teams kind of set a cutoff and say, you know what, if we can't do it in this amount of time, we're going to shoot instead. But you guys have gone under the 4 seconds, as you're saying. So why was that so important to get that quick timing for your robot?
It gives us a lot more freedom to shoot more balls. Yeah. Less time climbing is more time scoring. So
less time climbing, more time scoring. I think we put that on a banner for you guys or something like that. So, well, Black Hawk Robotics, really appreciate you taking the time to tell us more about your robot here. Good luck, of course, at the Texas State Championship, and we'll see you at the World's Championship as well. Can't wait to see more. Thanks a lot.
Thanks.
Thanks to Stryker Careers for their support in this video. First alumni and mentors are making Stryker a top priority for their internships and careers. That's because Stryker knows that those in first are the leaders and innovators of tomorrow. If you want to help make the world a better place by creating life-saving medical devices and technology, get started at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.